recording again. But as you can see, though, that AC method, as it's called, that's a new technique. And this is going to allow us to do more factoring. Before, if you remember, wait, hold on. Okay, it's recording, good. Before, hopefully you remember, we were able to factor this kind of trinomial. X squared plus bx plus c. You know, we were able to factor that. But now we're going to get a little more general and go from here to here. Namely, we're going to say, well, we're going to ask, well, what if the leading coefficient a here is not 1? Can't be 0, but it's also not 1. The case when it was 1, we handled that. Okay, well, what do you do if it's not 1? Well, here's the procedure. And don't worry, you don't have to memorize this. It's in the notes. Okay, now, what do? Well, you factor out, you find and factor out the GCF. Now, then you're going to find two numbers whose product is a times c and the sum is b. Let me say it again. The product a times c, right? A is the coefficient of x squared, the leading coefficient. C is the constant term. You're going to multiply those two together. Then you want two numbers whose product is a times c and whose sum is b. B is the coefficient of x. Then you're going to replace b with that sum. And you'll see when we do some examples, you'll see in doing so, you're essentially converting the polynomial, this trinomial that is, into one with 4 terms. So what do you do then? Factor by grouping. So essentially, we're going to convert this into a polynomial with 4 terms and apply factor by grouping. Okay, so that's the procedure. So I pressed the key too fast. When we do some examples, it should make more sense. So let's do some examples. So here's our first one. And again, notice there's 3 terms. It's a trinomial. The degree is 2. The leading coefficient is not 1. It's 5. So let's try this method and see what happens. Okay, so we want to find the GCF of this. Now, hopefully you can see that it's 1. And why is that? Well, there's a non-zero constant here. So there's no x here, right? So we take that m to be 0. In other words, we can't factor out x. But also, if you were to list the factors of 5, 11, and 2, you would see that the only factor in common is 1. If you list the factors of 5, you get 1 and 5 only. 11, you get 1 and 11. 2, you get 1 and 2. So the only thing in common would be 1. I mean, I know I didn't write it, I said it, but you should be able to write it out on your own. But because the only common factor is 1, so that tells us the greatest common factor of 5, 11, and 2 is 1. So our GCF would be 1 times x to the 0, which is 1. Now, what do we do next? We're going to apply the rest of the method. So what do we do? So notice by comparing the polynomials, we have 5 is a. 5's taking the role of a. 11 is taking the role of b. 2 is taking the role of c. You know, just by comparing coefficients. So we're going to form the product 5 times 2, and that's 10. So by the AC method, we want two numbers whose product is 10. but the sum whose sum is 11. In other words, you want to fill in those blanks. Okay, well, what numbers are going to pull that off? Well, probably be the first choice, 10 and 1. And it turns out it is, right? 10 times 1 is 10. 10 plus 1 is 11. So 10 and 1 are the numbers we want. Again, we want 10 and 1. 10 times 1 is 10. 10 plus 1 is 11. You know, sometimes, as we saw earlier, the first choice may not work. Try something else. Okay. So we're going to so as I said in the method, you'll see now, we're going to replace 11 here with 10 plus 1. You're replacing the coefficient here with that sum. That's what I did here. And as the red marks are showing, you're going to have some distribution, you know, distributing the x. And why do we do that? We now have a polynomial with 4 terms. As you can see, we now have a polynomial with 4 terms, and we want to factor this. So what do? Factor by grouping. So we're going to do some factor by grouping. Okay? So that's what we have here. Okay, let me just pause this a second. Before I keep going, let me just